Hi guys, and welcome to this video that is about direct variation. That is what we're going to be learning about today, so I hope you learn a lot. Jumping right on into it, the equation for direct variation is y equals mx. Okay, y equals mx is the equation we have been using throughout the whole proportional relationships unit. So this shouldn't surprise you. This shouldn't come as a surprise. So in the formula, like we've been talking about, what have we been saying m equals? Let's take a couple seconds, think to yourself, what does m equals? Well, if you thought to yourself that m equals slope, you're correct. Remember guys, m is just a variable we use for slope. And we've already talked about slope. So you guys should know that slope equals what? What does slope mean? Think to yourself for a couple seconds. Oh yeah, slope means rise over run, which what we've been talking about with graphs and tables, how much your y value goes up over how much your x value goes up. So just remember, rise deals with being up and down. That's your y-axis. Run means left to right. That's your horizontal axis, which is your x-axis. And that should be review at this point. We've gone through this. You guys should know slope is rise over run, which is really just y over x. So, when we talk about slope in the direct variation lesson, we don't just call it slope. Direct variation calls it something special. And that special name is the constant of proportionality. So let's go through that one more time, okay? This is the big thing about the direct variation lesson, is that we don't call it slope. When we talk about direct variation, we're really talking about the constant of proportionality. So whenever you see constant of proportionality, the first thing you should think of is just slope. It's just another fancy word for slope, okay? So don't get all confused. Remember, proportional relationship unit, we've learned that there's many things that are called slope. And like we just stated, the slope for direct variation, we call that the constant of proportionality. So let's go over here and look at this table, okay? On a table, to say that it has a direct variation, you have to have two things. You must be able to say you could plot 0, 0 on that table if needed. Even if it's not on there to begin with, like here, you don't see a 0, 0. So this table deals with pounds, price per pound pretty much. So if you think about it, put our thinking caps on. If we think about it, if you didn't buy any pounds of strawberries, of apples, grapes, bananas, whatever, if you don't buy any, do you have to pay a price? No. So sometimes, 00 won't be listed on there. You have to use your noggin to figure that out. So we look here. Okay, so we know the first thing, it has to have the ordered pair of 00. Next, it must have, guess what? The same ratio, okay? Throughout it all, like we've been doing. But we need to make sure that we put our y over x each time. So, did I just say ratio? Yeah, because I'm dealing with slope, my y over x. Okay, so we have our x values, we have our y values. Let's see how much the x goes up by each time. Well, 1 to 2 is plus 1, 2 to 3 is plus 1, and 3 to 4 is plus 1. So that's awesome. Those are all plus 1s. Let's look to see how much our y's go up by each time. 2 to 4 plus 2, 4 to 6 plus 2, 6 to 8 plus 2. So that's awesome too. The one thing about direct variation is we need to make sure that those ratios are actually the same ratios each time. So you have to, go to the side, think in your head, okay, we have 2 over 1, 2 over 1, 2 over 1. So all those ratios were 2 over 1, 2 over 1, 2 over 1. So guys, like we've been dealing with, if the ratios are the same each time, that means it has a constant of proportionality of what we said was each of them were 2 over 1. So the constant of proportionality is, yeah, guys, it's 2. So they have to have the ordered pair 0, 0. And, of course, like we've been doing throughout this whole unit, it has to have a constant of proportionality. AKA, you have to have equivalent ratios or slopes or rate of change throughout each thing, okay? So once again, nothing new, but we just change, the word slope from constant rate of change or ratio to what's the constant of proportionality. So constant of proportionality, remember, is a fancy smancy word for slope. Is your slope the same each time? Is those ratios the same each time? So that's all about tables. Now for graphs, guys, it's simple. I want you to think to yourself, what makes a graph proportional? Let me give you a couple seconds. What makes a graph proportional? Well, guys, what makes a graph proportional is it must go through the origin, which is 0, 0, and it must be a straight line. So it must go through 0, 0, and it must be a straight line. Meaning, the slope has to be the same throughout the whole graph, or the constant of proportionality must be the same the whole time. So if we look at this graph, we see that it just says, does this graph show direct variation? Well, if we look at it, does it go through the origin? Check. Does it make a straight line? Check. So that's all we need to see from a graph to know that direct variation is happening. So you would say, yes, this graph does show direct variation because it goes through the origin and it's a straight line, or it's linear. The line's linear. So guys, let's recall what we've learned, kind of during the whole proportional relationship unit. So slope can mean 3 things. It can mean, of course, ratios, like y over x. Or rise over run. We also know slope as the rate of change and last but not least, guys, we know it as what we learned today with direct variation, the constant of proportionality. So thank you guys for watching this video. I hope you learned about direct variation, and have a wonderful night.